Homework 2.7, Inverse Functions, Video 4. Homework due Friday, May 22nd, 2020 at 11:59 p.m. Hey, I remember to change the video number, but I forgot to change these. What I'm about to show you will pertain to homeworks 4, 5, 6, 7. Homework questions 4, 5, 6, 7 in homework 2.7. And also at the end of the video, I was rambling about how I'm going to do this now instead of the end of this series. When I looked over there, it is what I had scheduled to do now. So, whatever. So, when does a function have an inverse? And specifically, what was wrong with f of x equals x squared that made it not have an inverse? Well, we could say it's the domain range issue, and you would be correct, but there's another thing inherently wrong with this function that caused it to never have an inverse in the first place, at least not as is. At the end of this video, I'll show you how you can adjust it so that it technically is an inverse, and it'll address the sort of that I forgot to address at the end of the last video. Well, do you remember the example I used in the last video to show you why the square root of x was not the inverse of this? At the beginning, I said, give me a number, 7, okay. 7 squared is 49, the square root of 49 is 7. I got back the 7 that I started with. But then what did I do? I used negative 7. The problem with this function is that when I put in 7, I get an answer of 49. But when I put in negative 7, I also get an answer of 49. Now, why is that a problem? Because if there were an inverse function, we'll call it g just for a moment. Well, actually, let's call it what we should call it, which is f inverse. If there were an inverse function of this, what would it turn the 49 back into? Would it turn it back into the 7? Would it turn it back into the negative 7? Or would it have to turn it back into both? Well, forget both. A function can only produce one value at a time. Remember, each x is paired up with only one y in a function. So we run into a problem here because, the function that we were trying to find an inverse of took two different numbers, two different inputs, and turned them into the same output. So there's no inverse function that could possibly take that output and turn it back into both 7 and negative 7 at the same time. So let's see if we can make this a little bit more concrete by looking at the graph of f of x equals x squared. Again, we know what it looks like. It's a parabola. And this may not be drawn to scale, but let's just say that 7 is here and negative 7 is there. And you may have noticed what I was doing to locate them, because I know that both of these go up 49. So we'll say that this is the point 7, 49, and this is the point negative 7, 49. There's a couple of ways to describe what's going on here. Number one is visually on the graph. We have 2 points on the graph that are on the same horizontal line. If I drew the horizontal line, y equals 49. It hits the graph in 2 places. Because those 2 points lie on the same horizontal line, we know that they have different x values but the same y value. In other words, this scenario, 2 different inputs produce the same output, which made it impossible to reverse it with a function. No one function will take 49 and turn it back into 7 and negative 7 simultaneously. So there's a visual way to look at a function's graph and go, you don't have an inverse. If you can cross it with the horizontal line and intersect the graph more than once, then the function does not have an inverse. This sounds a lot like something we saw earlier. Do you remember the vertical line test, which answered the question, are you a function? Vertical line hits it more than once, you're not a function. This is, appropriately enough, the horizontal line test. And the horizontal line test answers the question, are you invertible? So it goes like this. If you can cross a function's graph more than once with a horizontal line, so that horizontal line crossed the graph more than once, then the function is not invertible, which is another way of saying it does not have an inverse. So now we got a real quick visual way to go, yes, you have an inverse, no, you don't. Because the graph of f of x equals x squared fails the horizontal line test, that function never had a chance of having an inverse. The questions in your homework 4, 5, 6, and 7 are just horizontal line test questions, so they're pretty easy. But I want to go back to the sort of that was left unanswered in the previous video. Just to kind of put it back in context, we had f of x equals x squared, we had g of x equals the square root of x, we had set up g of f of x, which had set up the square root of x squared, and then I wrote x, and then I wrote sort of. Here's why it was sort of. The range of the square root function is 0 to infinity, including 0. In other words, the square root function can only give you back non-negative numbers. It can give you back 0, it can give you back positives, but it can't give you back negative numbers. If I put a negative number here, like -7, I can't put -7 there because square roots don't come out negative. So when I said sort of, and this is something I've just been kind of glossing over up until now, this statement is not true all the time. This is true only if x is greater than or equal to 0, and that's the sort of. Now don't panic, squares and square roots will still cancel when we need them to. And by the way, when we solve quadratic equations by dropping square roots, do you remember that we had to put a plus minus? That's why we didn't have to worry about this then. So yes, square root of x squared equals x, but only if your x is not negative, only if it's greater than or equal to 0. So that's what the sort of is about. But I don't want to totally abandon this problem because I don't want you leaving thinking that squares and square roots won't cancel each other. They will under the right conditions. The condition being that you don't mess with negative numbers. So does that mean that this does have an inverse? Well, not as is. The answer to what was wrong with f of x equals x squared is that the graph fails the horizontal line test, which I'll abbreviate HLT. Now, there's another way to describe what's going on here that's not visual, and it's about the function itself, not the function's graph. Also, f of x equals x squared is not, and I'm about to introduce a new phrase, quote, 1 to 1, which is usually hyphenated. Now, what does it mean for a function to be 1 to 1? Well, you know how a function, if you put in 1x, you can only get out 1y? A 1 to 1 function goes backwards. You can only get 1y from 1x. So when we said f of 7 equals 49 and f of -7 equals 49, this is an example of the function being 2 to 1. 2 inputs paired with 1 output. 1 to 1 means 1 input for 1 output and vice versa. There's a stricter definition of 1 to 1. The stricter definition is if a function produces 2 equal outputs. So we'll say if you put in 1x and another x and they come out the same, like when we put in 7 and -7, they came out the same. A function is 1 to 1 if equal outputs implies equal inputs. In other words, the only way you can get an answer out is putting in the same inputs. So the only way I could get out 49 is putting in 7. Oh, except it's not. I can put in 7 and -7. So in the homework, when it talks about a function being 1-to-1, that means the only way the outputs can be equal is if the inputs were equal to begin with. This function wasn't 1-to-1 because having equal outputs like 49 did not guarantee equal inputs like 7 and -7. But it's much easier to check a graph to see if it fails the horizontal line test than it is to check a function to see if it's 1-to-1. In the homework, when you see problems saying this function is 1-to-1, what they're basically saying is it has an inverse. All right, so last thing, because I don't want to let this f of x equals x squared go until I convince you that they are inverses under the correct conditions. So give me 1 second to reconstruct the parabola. Its domain was -infinity to infinity. Its range was bracket 0 to infinity. And reconstruct what we thought was the inverse of f, the square root of x, which was the top half of a right opening parabola, whose domain was 0 to infinity, and whose range was also 0 to infinity. As is, these are not inverses for the reasons I've discussed ad nauseum, but there is a way to make them inverses because there is a way to fix this mismatch. We can do what's called restricting the domain. In other words, this domain is too big to match that range, so let's restrict it. And by restricting it, I mean let's cut it down until it matches that. But what would that do to the graph? If the domain started at 0, then the graph would start here and we would have to erase that half of it. So if we impose the restriction that this is the function if x is greater than or equal to 0, that cuts off the left half of the parabola, fixes the mismatch, and now they're inverses. So the moral of the story is squaring and square rooting are inverses as long as you don't dabble with negative numbers. As long as you got the horizontal line test, you're going to be okay.